Okay, sir.
So good morning, everyone, and welcome to this lecture. I think this is Modern Physics lecture number 3. And I hope you remember what I told you in the previous class. What I told you in the previous class? Do you recollect?
Work function.
Work function. Okay, so you recollect that before coming to every class, you have to. Did you do that? I mean, what I told you in the last class?
Yes, sir.
What did I tell you? What did I tell you to do from the next class on?
Revision.
Okay. So I hope you have done revision and we remember that we had done something known as work function. What do you mean by work function of any metal or any body? It is the minimum energy required so that it can emit photoelectrons. Yes or no?
Yes, sir.
If I want to have photoelectric effect, the energy of this radiation has to be more than what? The energy of this radiation has to be more than what? The energy of the falling light should be more than something, more than a certain value. What is that value known as?
Work function.
That is known as work function. The frequency has to be more than a particular frequency. That frequency is known as?
Threshold frequency.
And the wavelength should be less than a particular wavelength. And that wavelength is known as?
Threshold wavelength.
Threshold wavelength. We also seen two things, that the intensity of light, when I say intensity of light, I refer to the number of
photons.
When I refer to the energy of light, I refer to the frequency of photons. By increasing intensity, I can increase current, saturation current increases, but this only happens if the frequency is more than threshold frequency. We have also seen a voltage known as stopping voltage. If I apply that much of voltage, what happens is I can stop the photoelectric current. So far, so good. We remember all this.
Yes, sir.
Now, let us move ahead. Since we were talking about intensity and work function, there is one thing that again you should remember. Again, what am I going to tell you? A straightforward question will appear in your exam. So you note this point very, very carefully. And I hope that you have received this sheet.
No, sir.
No, sir, that is very bad, sir. It should have been given to you. I had a discussion last night. Anyways, I think it should be there with you by today. This is one thing that you must remember. Sometimes a question comes, a direct question comes in your paper regarding relating intensity with electric current or intensity with photons per second or intensity with the distance. If this is a light source, now remember, when we are talking about modern physics, we are also talking about light because we are letting light fall on particles. So this may be a question that comes in your optics, or this is a question that comes in your modern physics. If I have a light source, this is a light source, a point source, a light source. It emits light. Light is energy. Now, whatever energy, for example, if I take this as sun is emitting light energy. This is some surface. Energy is falling on the surface. Energy falling per unit area, per unit time is known as intensity. Do we remember it?
Yes, sir.
And this intensity of light depends on how many what?
Number of photons.
How many photons are falling on the surface. So we remember this relation always, and there would be, we might see in your sheet, there would be a question that has come on this particular topic where you have this simple relation. Energy of light passing through per unit area per unit time is known as intensity. I know this. Intensity is directly proportional to photons. How many photons are falling, or how many photons are falling per second. In terms Sometimes the question might refer, instead of photons, they might call it as electrons. How many electrons are emitted by the body, by the photosensitive body, to produce that photoelectric current? So it is also relevant that we can relate it to photocurrent. This is proportional to current, so we understand this. And this intensity is inversely proportional to R squared. Did I tell you that? Intensity of light source, if I go away, the intensity will reduce. Yes or no? And it follows inverse
Yes, sir.
square law. Do we remember this? It follows inverse square law. Yes or no?
Yes, sir.
So intensity is directly proportional to capital N, which is the number of photons, or it is directly proportional to small n, which is the number of photons per second, or it is directly proportional to the photoelectric current I, or it is inversely proportional to R square, where R is the distance. Do we understand this? There would be a straightforward question that comes on this. If you know this, you should be able to solve it. I'll give you a minute to note this down. I hope no one has any problem or any doubts with this one. Yes or no?
Yes, sir. Understood.
Please note it down. You have a minute, 2 minutes. Have you noted it down?
Yes, sir. Done.
Then again, some points that you must remember. Again, a question based on this point will be coming in your exam straight away. Golden key points. I think I've discussed this point before. Photoelectric effect is an instantaneous process. As soon as light is falling, electrons are emitted. I think we have discussed this, so no point. You can just note it down. The second point is stopping potential does not depend on the distance between the cathode and the anode. Do we understand this? No matter you make the distance very large or very small, the stopping potential will not depend on it. On what factor does stopping potential depend on? Tell me. How can I change the stopping potential? How can I make the stopping potential more, or how can I make the stopping potential less? On what factor does the stopping potential depend on? Question. Give me the answer.
Intensity of light.
It depends on the...
Intensity of light.
No, it does not depend on the intensity of light. Again, you've not read, you've not gone through the class thoroughly. Stopping potential depends on the only two things. Either there is intensity of light, which is related to the number of photons, or it is the energy of light, which is related to the frequency of photon. If I have said the first option is wrong, the second option has to be correct. Stopping potential depends on
Frequency of photon.
frequency or the energy of photons. It does not depend on the distance between the cathode and the anode. I hope this point is clear. I move on to the next point. The work function, someone asked me last day. Work function depends on temperature. No, it is work function depends on what material this is made up of. Does not depend on temperature. The work function represented the energy to remove the least tightly bound electrons. Remember that. From the surface. It depends only on the nature of the metal, bacha, nothing else, and independent of any other factors. Do we all understand this? Are all doubts clear about work function? Yes or no?
Yes, sir.
I'll give you a minute to show me your talent, to note this down securely in your notebooks. Every word that I utter here, every word that I utter here are golden words for you, because the question that you see in your examination hall will be coming straight forward. Please trust me, the question would be straight forward, straight forward, Straight forward. Straight forward. I hope you have understood the emphasis of straight here. Yes or no?
Yes, sir.
It would be straight forward, right, straightforward from what I have spoken in the class. So class and words spoken in the class become very, very important. Have you noted this down?
No, sir.
Please note it down. I'll give you a minute, 2 minutes.
Done, sir.
Well done, sir. If you have done, sir, then we move on to the next point. And again, it is just an explanation. You can read this explanation. And again, straightforward question would be coming if it comes. So we have said that what photoelectric effect is an instantaneous process. Why it is instantaneous process? One photon, tung 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 tung, strikes one electron, tung 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 tung. It transfers its energy immediately, and immediately the photoelectron is emitted, and that is why it is an instantaneous process. And this photon must have sufficient energy to liberate this electron. It must have energy more than work function. It must have frequency more than threshold frequency. It must have wavelength less than the threshold wavelength. It strikes, it transfers energy instantaneously, and the electron is liberated. Do we understand this?
Yes, sir.
So because we are thinking it as number of photons striking the metal surface, that is why this process becomes an instantaneous process, because one particle is striking the other particle. That is why particle theory of light, this explanation can only be done by particle theory of light, where we consider that light is not a wave, but light is a particle.
Yes, sir.
Do we understand this?
Yes,
Is it
sir.
clear to everyone? So
Yes,
this
sir.
can only be explained by this theory, particle theory. Since it is an instantaneous process, it is explained by the particle theory. The next thing again, it's an explanation of why it does not depend on the intensity of light. Why saturation current depends on the intensity of light, and why the stopping potential does not depend on the intensity of light. Intensity of light, you can see on your screen, intensity of the light refers to the number of photons. If I make more photons to fall, more electrons can be liberated, and hence we will have more current. The value of saturation current will increase. But if and only if this will happen if the energy of the photon is more than the work function We cannot change the stopping potential by changing the intensity. We can only change the saturation current. Stopping potential does not depend on intensity. Stopping potential depends on frequency. Do we understand this?
Yes, sir.
Yes, sir. No, sir. Then you write it, sir. That is the second point. Again, an explanation of the same fact. And remember, questions would be coming straight forward. Straight forward. Understand the emphasis on the word straight. Straight forward. I hope you have noted this down. You have understood this. These are the only three or four points you have to remember. All the question in the entire universe that can be made and presented to you in your exam will be coming from these 3 points. If you understand these 3 points, the questions are done. Have you noted this down? Yes or no?
Yes, sir.
Yes, sir. No, sir. Then, sir. Yes, this, sir. Come, sir. This is known as the Einstein's equation. Have you seen this Einstein's equation? This equation is known as the Einstein equation, and you will be pretty surprised to know Sir Albert Einstein. You know that Sir Albert Einstein got a Nobel Prize? Yes or no? For physics? Yes or no?
Yes, sir.
For what did he get the Nobel Prize? For what did he get the Nobel Prize? He had given so many fascinating stuff. For what particular thing he got the Nobel Prize? Do you know? Nobel Prize in physics. This equation he got the Nobel Prize. Do we understand this?
Yes,
So this
sir.
is probably one of his best work because that gave him the Nobel, not this theory of relativity or theory of special relativity. This gentleman got him the Nobel Prize. You understand this?
Yes,
The
sir.
explanation of the photoelectric effect and the Einstein's equation. This equation, not E is equal to mc square. E is equal to mc square is more famous. This is the equation that got him the Nobel. Okay. One
Okay.
photon interacts with one electron. Do we understand the first line?
Yes, sir.
Yes, sir. No, sir. Then, sir, what, sir? Now, we all understand law of conservation of energy. Energy cannot be created, energy cannot be destroyed. Yes or no?
Yes, sir.
This photon has an energy. Let me call that energy as E. Do we understand this? This is the total energy this photon has. Now, it is going to strike the electron. It is going to strike the electron, and let us assume that this energy that this photon has is more than the work function. If this energy E that the photon has is more than the work function, then what will happen? Electrons would be liberated, yes or no?
Yes, sir. With some kinetic energy.
Well done, bacha. So some amount of this energy will be required to overcome the work function. Do we understand this? For example, if the work function of this metal is 2 joules, and again work function is not in joules, it is in electron volts. I just don't want to use electron volts. Let us use electron volts now. Let us get used to electron volts. Let us assume that the work function of any particular metal is 2 electron volt, 2 eV. And the energy that this photon has is 5 eV. It has to be more, otherwise nothing happens. We understand this? Yes or no?
Yes, sir.
Now, here this 5 eV and the other side there is 2 eV. Energy cannot be created, energy cannot be destroyed, it can be always transferred from one to another. So now there is some energy that is left. There is some energy that is left. There is some energy that is left. Where will that energy go? 5 electron volt here, 2 electron volt there. Some energy is left. Where will that energy go? Energy cannot be created, energy cannot be destroyed. Yes, tell me, where will that energy go? Energy cannot be created, energy cannot be destroyed. It is only transferred from one form to another. Where does the 3 electron volt go? Tell me.
Heat loss.
Some energy may be lost in the form of collision. We can call it as energy lost in collision or energy lost in the form of heat. Do we understand this?
Yes, sir.
But when the electrons are liberated, they'll also have one more energy. Which energy are we talking about? Which energy? Which energy? Which energy are we talking about? This photon, dung, 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 dung. Go back in the past. This photon was striking the electron out. The electron was getting out, and it was having somewhat.
Kinetic energy.
Yes. So the rest of the energy has to go in the form of kinetic energy. Do we understand this?
Yes, sir.
So this is Einstein's equation. Law of conservation of energy, nothing else. This is Einstein's equation, where W naught stands for the work function, delta Q stands for energy which is lost during collision in the form of heat or any other form which cannot be utilized. Ke stands for the kinetic energy of the particle. Particle is the electron which is being liberated. I hope you understand this. Now, if I take a very special case where this heat loss is neglected, so I assume that no energy is lost in the form of heat. So what I'm assuming here is, it's a very specific case and it is a very difficult case to understand. So what I'll do is stop this thing and I'll get myself on big screen. I like coming on the big screen. So this is my what this is my electron which has to be liberated out. And the liberation army is this photon. It moves like this. It does not move like this, moves in a straight line. So now what's going to happen is this electron is moving like this. Now this photon strikes this. Now when this strikes this chota tha photon or chota tha electron, this electron is going to come out. Yes, but you must understand that we are striking a metal surface, and this metal surface is millions and billions of electrons, and this millions and billions of atom, and this millions and billions of atom has millions and billions of electrons. So when this chota sa electron gets energy, it will not come out directly. There will be collisions happening. Yes or no?
Yes, sir.
And where there are collisions happening, there will be energy which will be lost in the collisions. Yes or no?
Yes, sir.
But we are taking a very, very special case where nothing of this thing happens. And this electron, as soon as it gets energy, just moves out without colliding. So there is no collision happening. Do we understand this?
Yes, sir.
Now, if there is no collision happening, then what will happen, my dear friends? If there is no collision happening, delta Q or Q is 0, the electrons which are coming out, they will come out with maximum kinetic energy. Do we understand this? If delta Q or number of collision is 0, the kinetic energy of the electrons would be maximum. Do we understand this?
Yes, sir.
Yes, sir. No, sir. Then, sir. What, sir? I have this equation, sir. And that is the equation that you see in books. That is the equation that you must understand. But the original equation is the equation that I am going to do. This is the original equation. Do you understand the original equation?
Yes, sir.
But the equation that I'm going to write now is the standard version of this equation where I've assumed that this is 0. Do we understand this?
Yes, sir.
And in this case, the kinetic energy is maximum. Do we understand this?
Yes, sir.
And this is how the equation now looks like. The total energy E of the photon that is striking it becomes equal to W naught. The W naught stands for the work function plus Ke max. Do we understand this?
Yes, sir.
And this equation is known as Einstein's equation of photoelectric effect. And this particular thing gave Sir Albert Einstein the Nobel Prize. Do you understand this?
Yes, sir.
So this is the Einstein's equation, which you have to remember. This is a special case where delta Q is taken as 0. Now, I can write this equation in different forms. This is the first form in which I have written this. You understand what is this H into F? What is this H into F?
Energy.
Energy of the photon. This is the kinetic energy of the electron. Maximum kinetic energy. Do we understand this?
Yes, sir.
And this is the work function W naught. So I can now write kinetic energy, maximum kinetic energy as H into F minus work function. Do we understand this?
Yes, sir.
Now this maximum kinetic energy can be written as E into V naught. Remember the formula that I told you? Maximum energy I need to stop. It must be equal to E into V naught, where V naught is the stopping potential. Do we understand this?
Yeah, sir.
Did I tell you this equation? The maximum kinetic energy of the photons is equal to E into V naught. In the last class, did I tell you? If I did not tell you, or if you don't recollect, not a problem. You just write equation number 1, equation number 2. I mean, the number should be ulta shayad. This should be equation number 1 and this should be equation number 2. Then I will tell you more. You can write this equation number 1, equation number 2 and equation number 3. Can you write it till here? Yes or no? Up till here you understand this? Yes or no?
Yes, sir.
Then sir, please sir, write sir, up to here sir. I'll give you a minute to do this.
Done, sir.
Then sir, what sir? We move on, sir, to my sheet where I'll try to make more sense about this. Let us try to write all the okay. Let us try to write the Einstein equation. The original form of Einstein equation, which is form number 1, this E is equal to W naught plus kinetic energy of the electrons plus delta Q. Do we understand this first equation?
Yes, sir.
Number 2 equation I make when delta Q, the energy lost in collision, is 0. Then I have this Krantikari equation coming up, W naught plus maximum kinetic energy. More than 99.99% of question will be based on this equation. Do we understand this?
Yes, sir.
In third case, what I'm going to do is just write this energy as H into F. That will be equal to work function plus kinetic energy maximum. Do we understand this?
Yes, sir.
Now I can write this as HF is equal to H into F naught plus kinetic energy maximum. Do we understand this?
Yes, sir.
Where what is F naught? What is F naught?
Frequency.
What is F naught?
Threshold frequency.
Yes, F naught is your threshold frequency. Oops, wrong color. F naught is your threshold frequency. Yes or no?
Yes, sir.
Yes, sir. No, sir. Then, sir, what, sir? I can write it in this form as well. Hc by lambda will be equal to Hc by lambda naught plus Ke max. Do we understand this? Yes or no?
Yes, sir.
Pakka, sir?
Pakka, sir.
Okay. Up till here, no problems with anyone. Now, what we should see is the relation between maximum kinetic energy and the work function. Now, what is maximum kinetic energy and stopping potential? What is stopping potential? When the electrons are getting liberated in that cell, in that Leonard experiment. If I make anode as cathode and cathode as anode, at some point the photoelectric current stops. Yes or no? We remember this?
Yes, sir.
Now, to stop photoelectric current, what I need to do? I need to stop the electron which is moving with the fastest speed. Yes or no?
Yes, sir.
If I can stop the fastest electron, I can definitely stop all the electrons. Yes or no?
Yes, sir.
That means stopping potential is related to the speed of the fastest electron. Yes or no?
Yes, sir.
That means stopping potential is related to the kinetic energy of the fastest electron.
Yes, sir.
That means it is related to the maximum kinetic energy. That is the sixth thing that you must understand. The stopping potential V naught is dependent on proportional to the speed, the maximum speed. It is proportional to the maximum kinetic energy. Do we understand this?
Yes, sir.
So I can write it in a different way. We remove the proportionality sign. The kinetic energy maximum, the maximum kinetic energy is E into V naught, where what does E stand for?
Stopping potential. Not V is
V naught stands for the stopping potential, and
speed of light.
E stands for charge of the electron. Bacha, C stands for speed of light. Don't get confused and don't become Ghazni, because then you will be leaving things in the stomach. And that would be going to be a big pain. Please don't do that. Do we remember what is E now? Small e, small e. Small e is always charge of the electron, bacha. It cannot be anything else, bacha.
Okay.
Okay, sir. Yes, sir. Okay, sir. Fine, sir. Everything looks good, sir. So these are the different forms. Instead of maximum kinetic energy here, I can put the value here. So I get one more equation. I can put the value here. So I get one more equation. I can put the value here. I get one more equation. But that doesn't mean that they are not separate equations. But all the equations, all the equations that we are doing is coming from just one equation, and that just one equation is the equation in pink, my favorite color, written with red, my favorite color. That's the top one. Do we understand this? Yes or no?
Yes, sir.
3, 4, 5, 6, 7, 8, 9, 10. I can make 1500 equations, but the basic equation remains same. Are we clear with what we have done? I'll give you a minute, and whenever I give you a minute, I give you a minute to minute. So minute for you yourselves, and read all this. Have we written this equation, bacha?
Yes, sir.
Yes, sir. No, sir. Better I go, sir. Better we do, sir. Shall we move ahead in life? The
Yes,
only
sir.
thing that we should do in life is to move ahead, and we should move ahead, and we have moved ahead. And this is the question that has come. AIPMT, which is your NEET, or which is whatever. The question is right in front of your eyes. I just got to sit and relax, and you shall give me the answer. What function of metal surface is falana falana? Wavelength of light is dhimaka. I mean, 1.5 electron volt is the work function. Wavelength of light is 55,000 Armstrong unit. Light is falling on it. What is the maximum kinetic energy of the ejected electron? After that, there is some garbad, garbad, garbad. So forget that garbad, garbad, garbad. We will just rub it off. Spelling, oh, what should I say? Not spelling. Call this typing mistake. Typing mistake. Can I have answers to this question, please? The time starts now. Till then, I shall just find out more questions. This one, and this one. Yes. Any hopes? Have you got the answer, bacha? Anyone with an answer?
.45.
See, the options are there. Were A, B, and
Option
C.
C.
Option C. Let me see. I have to calculate, so I just check out the answers from here. This is question number 3, and my dear friend, the answer is B. 0.98. The answer is given as 0.98 in my answer sheet. Is it 0.98? How did you get it? How do you get 0.45? Shall I do it or shall I give you more time?
You can, sir.
Wait, sir. Okay, sir. As you say, sir. No, the answer may be wrong. I mean, I don't trust the answer. I just trust the solution. How you have done this. I'm not very I'm very fond of answers. Answers may be wrong. I mean, someone might have done it wrongly, so it doesn't matter. Shall I do it?
Okay, sir.
You have given up?
Answer is B, sir, coming 0.9.
Answer is B, sir. Coming, sir. Then, sir, the answer in the book, sir, is also right, sir. So, sir, we shall move on, sir. How you do it? It's very simple, pretty damn simple, and this is how you should do it. We have, this is question number 3, I guess. We have the wavelength given as 5,000. You don't have to write this because you will be losing a lot of time, and time is one privilege that we don't have in the examination hall. Do we understand this?
Yes, sir.
Just showing it to you stepwise, nothing else. You have to do it in a flash. You can calculate the energy of this gentleman. How much will be the energy of this gentleman? Hc by lambda. Hc, I know how much is that. 12,400. Do we remember this?
Yes, sir.
12,400 divided by 5,000. So 220 go away. 10 comes here. This becomes 12.5. I divide 12.5 by 12.4 by 5. I can't tell you how to divide this. I'll just leave it here. So whatever comes, what is coming?
2.4.
2.4. 2.4. 2.4 something else. 2.4 something else also, na? 2.4 something else. Okay, I think 2.48. Is that so? Anyway, still 2.4. We remain on 2.4. So energy is coming as 2.4. This energy must be equal to work function plus maximum kinetic energy. Yes or no?
Yes, sir.
Just put the values. Get the answers. Stay happy. This is 2.4. This is 1.5. plus the maximum kinetic energy. From here, you shall get the value of maximum kinetic energy. And I think it is not 2.4, it is 2.48, I guess, right? So the answer is 0.98. Do we all get this? Can I have some raise hand that we understand this, sir?
Yes, sir. Understood.
Boys, girls, can I have some raise hand that we have understood this? Raise hands like this, that
Yes,
we have
sir.
got the answer.
Yes, sir.
Okay. Where did my screen is there now? You can see my screen, right? Okay, this is how this question has to be done. I hope we have understood this question. Pretty damn simple. Pretty damn simple. You don't have to solve everything. What I'll do is I'll just formulate one question because I may not find that question in the sheet. So I'll just formulate this question for you, and I hope that you give me an answer because I have to make a point over here. So I'll write the question like this. The stopping potential of a metal surface is 4 volt. Just want to describe this question. The stopping potential of electrons which are emitted is 4 volt. The work function of the metal surface is, let us say, 1.5 electron volts. The stopping potential for a given metal surface is 4 volt. We have found out. The work function is given as 1.5 electron volts. Can you tell me what is the energy of the photon that is falling? What is the frequency of the photon that is falling? And what is the wavelength of the photon that is falling? Is the question clear to everyone? Is the question clear to everyone?
Yes, sir.
Stopping potential for a photoelectric current is given as 4 volt. Work function is given as 1.5 electron volt. Find out the energy of the radiation, energy of the photon, frequency of the photon, and wavelength of the photon. I hope you should be able to do this. Yes or no? You can do this. Yes or no? Tell me. Fatafat, fast.
Yes, sir.
Well done, sir. I hope that same thing, sir. Get the answer? Got the answer, bacha? Shall I do it?
HF is equal to 5.5.
Okay. Energy is 5.5. That is what you are saying? 5.5 electron volt.
EV not 4.5.
Okay. Once you get this, you should be able to get this. What I meant to say was, I just wanted to make a point here that stopping potential is always given in volts. Now, how do you connect or convert this volt into electron volt? You just write an E and it becomes an electron volt. So basically your stopping potential is 4V, 4 volt, and the stopping potential is related to your work function. Yes or no?
Yes, sir.
Your work function becomes E into V naught. So you just multiply E with 4V. So it becomes 4 electron volt. This is the point that I had to make. And that is why I had given this question. Do we understand this?
Yes, sir.
The stopping potential is not related to work function. That was the mistake I made. It is related to the maximum kinetic energy. Got it? I wrongly wrote it and you also said yes. Remember, do not make stupid mistakes. Got it? So the maximum kinetic energy is 4 electron volt. Yes or no?
Yes, sir.
See, sir, when I say something with confidence, sir, you also say yes, sir. You should remember that stopping potential work function does not depend on the stopping potential. Will you remember it now? And
Yes, sir.
no, not keep on saying yes, sir. Whatever sir says is yes, sir, yes, sir. Whatever sir not says is no, sir, no, sir. Whatever sir says is correct, sir, correct, sir. I may also say wrong things at times to understand whether you are paying enough attention or not. So I know the maximum kinetic energy. So this is how you convert stopping potential into maximum kinetic energy. That was the point I wanted to make out. Got it?
Yes, sir.
I made it out in a different way just to make you understand that just multiply volt by E and you have your answer in electron volts. That was the point. Okay, so kinetic energy maximum is known to me. Work function is also known to me. 1.5 EV, everything is in EV. I don't have to do anything now. I just find the energy of the incident photon that will be equal to maximum kinetic energy 4 EV plus 1.5 EV. So my this thing becomes 5.5 electron volt. Once I know this, that must be equal to SC by lambda. SC is 12,400. Do we understand this?
Yes, sir.
Divided by lambda. From here, I can find out lambda. Lambda will be 12,400 divided by 5.5, and this answer will come in Armstrong unit. Do we understand this?
Yes, sir.
You get the value of lambda. You know relation between lambda, C, and F. From there, you can calculate C is equal to F lambda. Do we know this equation? Yes or no? From here, you can calculate the frequency or you can calculate it in a different way. This is how questions are framed and this is how you have to answer them. Do we understand this? Yes or no?
Yes, sir.
Yes, sir. No, sir. Then, sir, please note it down, sir, so that I can move on, sir, to the next question, sir. And the next question, sir, is coming, sir, right on your board, sir. Have you noted this down, bacha?
Frequency.
You can calculate the frequency. I will not tell you how to calculate it. You can just multiply, divide, and get the answer. Okay?
Okay, sir.
Okay, sir. Shall I move on, sir, to the next question, sir?
Yes, sir.
Yes, sir. Then, sir, this, sir, here, sir. You see the question, sir, right on your board, sir. Light of wavelength, falana, falana. In photoelectric effect, gives electron of maximum kinetic energy 0.5 electron volt. This is how questions are framed. If the wavelength is changed to 2000 Armstrong unit, what is the maximum kinetic energy? Less than 0.5. 0.5. 0.5 is definitely not the answer. Greater than 0.5, this is definitely not the answer. So the only two options which are possible are, and again, A and D. Yes or no? Or okay, let me not confuse you because you might be confused. You only decide it. I don't want to confuse you. A, B, C, and D. These are the four options.
Less than 0.5.
less than 0.5 comes the answer, and think. See, they'll always confuse you with wavelength. When I decrease the wavelength, does the energy of the photon increase or decrease? Remember that they will confuse you there, and you got confused, bacha, and you have lost 5 marks straight away. Remember, a wrong answer does not lose you 1 mark. It loses you 5 marks. You understand the maths behind it? Panja, you understand the maths behind it? Just don't say, sir, a wrong answer only costs 1 mark, sir. I can go away with 1 mark. No, it costs you 5 marks because you also lose the 4 marks that you did not get if that answer would have been correct. So you've lost 5 marks in this question, bacha. And 5 marks can make a hell lot of a difference in your eventual rank. It can get you into top 5, top 10 of all India results, or it can lead to a fall of 15 to 20 to 30 to 40,000 ranks, and you will be out of the race for any college in this country. So the question is still in front of you. Shall you do? Are you doing it, or shall I do the rituals?
Do it, sir.
Do it, sir. You, sir, very easily, sir. Give it up, sir. That is not right, sir. This is very bad, sir. You have not tried, sir, and that is not going to help you, sir. But still, this is my job to do the question, sir. So I will do the question, sir. But still, I hope, sir, that you could have tried, sir. Because in the examination hall, sir, I, sir, will not be there, sir. You had to do the question with your own hands, sir. Got it, sir?
Yes, sir. It's coming.
Please, sir, try, sir.
0.5.
The answer is?
Greater than 0.5.
Okay, now the answer is drastically changed from less than 0.5 to more than 0.5. Remember, you're not playing Kaun Banega Crorepati, and I am not Mr. Amitabh Bachchan.
It's a
That I asked you, okay, are you sure, and shall I lock it? I can't do that. We are not playing Kaun Banega Crorepati. You can't guess. We are studying physics, my dear friends. It's not Kaun Banega Crorepati, and I definitely love Mr. Amitabh Bachchan, but I'm definitely not going to mimic him. Be like him. I just can't be like him. I have to be my own self. So how do we do it, sir? So, sir, we do it, sir, like this, sir. The first wavelength that is given to me, and again, I'm just doing it doing it in great detail. If you do it in such detail, you will not be able to solve this question in the examination hall, because in examination hall, you have to do, friends, 45 questions in 60 minutes. 45 questions in 60 minutes gives you about 1.2 minutes per question. That is a very less time. Very less time. Very, very less time. Very, very less time. Very, very less time. You can't do all this. You do it in your head, most of the things. So first lambda is given as 3000 Armstrong unit. Yes or no? Keep on saying. There's a 3000 Armstrong unit. I will not write the unit because I will still waste more time in writing the unit. Lambda is 3000. Yes or no?
Yes, sir.
From here I can find the energy. Yes or no?
Yes, sir. 12,400 by 3000.
And now I can't waste any time, sir, in calculation, sir. So tell me what is the answer, sir? 3.1 something. Yes or no?
Right, sir.
3.1. This will be enough for me to solve this question. 3.1 something something.
4.1 something.
Yes, 4.1, not 3.1. Yes, good. This was a genuine mistake. I did not do it knowingly. This was a genuine mistake. So this is 4.1. Okay. This is the energy. From here, kinetic energy is given. So energy is equal to work function plus kinetic energy. Do we understand this? Kinetic energy maximum. From here, I can calculate the value of work function. Yes or no? Yes
sir.
or no? So work function will be E minus maximum kinetic energy.
Right, sir.
What will be E? E is 4.1 minus 0.5. So the answer will be approximately 3.6 electron volts is the work function. Yes or no?
Yes, sir.
That's it, sir. Now we have to find out 2000 wavelength pe how much energy I have. So I write the wavelength as 2000 Armstrong unit. I will not waste time in writing Armstrong unit. I will just calculate the energy. How much is the energy of this? 12,400 divided by 2000. Yes or no? Yes or no?
Yes, sir. 6.2.
6.2, sir. So will the electron leave with more kinetic energy or less kinetic energy? More kinetic energy or less kinetic energy?
More.
More. So the answer is C. Do we understand this?
Yes, sir. Greater than
Now
0.5.
try to understand. Do I actually need to do all this to get the answer? No. I don't need to do all this to get the answer. That is where you save time. See, now you use your brain. Instead of doing all this, you use your brain and get the answer from your brain. If this was a question, okay. The problem in this question is one option is definitely wrong. Definitely not correct. Definitely not correct. Which one is that? Now let us try to use our brain and get the answer without solving anything. And that will probably also make us understand how questions like this may be solved orally using your brain and nothing else in a split second. Now tell me, one option is definitely wrong. I have solved the entire question, but now I'm asking you, based on what we have learned, you know that one option is definitely wrong. Which is that option which is definitely wrong? Which is that option which is definitely wrong? Anyone? Which is that option which can never be correct, whatever happens, even if I know nothing about it? The option that can never happen is that it has the same energy, right? Maximum kinetic energy cannot be same. Yes or no?
Yes, sir.
So this
0.5 B.
option is definitely gone out of the picture. Now see, I am not looking at this wavelength right now. I'm just looking at, I have two different frequency or two different wavelengths. This question can be put in two ways. In this book, in this year, it came in the form of wavelengths. In next year, it could have come in the form of frequency. So I'm not looking at wavelength and frequency. I know that two lights are falling. With one light, the maximum kinetic energy is 0.5. With another light, it cannot be 0.5. Yes or no?
Yes, sir.
This has got nothing to do with values. Yes or no?
Yes, sir.
One option is definitely wrong. Now the options which are possible are option number A, option number C, option number D. Remember, I'm not eliminating options. This is not the way of eliminating options. I'm getting the right options. In my head, how do I think? That is what I'm going to tell you. Now, remember, when frequency increases, energy increases. Yes or no? When frequency increases, energy increases. Yes or no?
Yes, sir.
If energy increases, the kinetic energy of the electrons will increase. Yes or no?
Yes.
So if this question was in frequency and the frequency would have increased, the answer is definitely only one. What is that answer? If frequency was the question and the frequency would have increased, there is only one answer possible. What is that one answer which is possible?
Greater than 0.5.
Yes, if the question was based on frequency, which is another question, and the frequency would have increased, only one option is possible, and the sahi option is greater than, because the energy has to increase. Can I have some raised hand that we understand this, bacha? Everyone, how I am solving this without using any calculation, without doing anything. Now, let us move on to the same question. This question is based on frequency, and the frequency has decreased. Now, what are the two options that are possible? Now, what are the two options that are possible?
Decreases less than 0.5.
Yeah, so it can be this option, but it can also be this option because the frequency may have become lower than the threshold frequency. Yes or no? Now two options are possible. Now, in this case, I will have to find out what is the threshold frequency. If the frequency of this radiation is more than threshold frequency, option is A. If the frequency of the radiation has become less than threshold frequency, the option is D. Do we understand this?
Yes, sir.
Now let us come to the wavelength wala part. Now, if this question would have been in wavelength, which is the question right now in front of your eyes, two things are possible in wavelength. When the wavelength decreases or when the wavelength increases. Yes or no?
Yes, sir.
When the wavelength decreases, only one option is correct. And what is that option?
Greater than 0.5.
Greater than 0.5. Because when wavelength decreases, energy increases. And in that case, the option is only C. So I have solved the entire question without using any pen, without using any value. Do we understand this?
Yes, sir.
The only problem will come when the question is on wavelength and the wavelength increases, because now there are two options which are possible. What are those two options? Options A, less, or option D, photoelectric effect does not happen. So in that case, I will have to find out the value of what? The value of threshold wavelength and see if the wavelength is more than threshold wavelength, photoelectric effect does not happen. If the wavelength is less, photoelectric effect happens, and the option is A. Do we understand this?
Yes, sir.
So that is how you solve question and that is how you get answers. Am I correct?
Right, sir.
Okay. Let us now move on to different questions and see if we can solve those questions. And remember, questions are pretty straightforward. This is the next question. Most of the question you can just answer by looking at the question and giving me the answer. So this is one in that category. I hope you see this. What is the answer here? What is the answer here, bacha? Tell me.
A.
A. Yes. A. Shall I move on?
Yes, sir.
Then, sir, this, sir. Coming to you right away, sir. I will not read out the question. You can read out and give me the answer. Oral questions, oral answers. When ultraviolet rays are incident on a metal plate, then photoelectric effect does not occur. It occurs by the incidence of
X-rays. Option B.
why X-rays? Why not the others? We are talking about question number 10. Now, this question number 10 is based upon your knowledge, what you remember about X-rays, radio waves, light wave, visible light. So basically, this deals with what? This deals with whether you know their wavelengths. Yes or no?
Yes.
Yes or no? Do you understand this? So you must know which wavelength is smaller. Infrared, visible, ultraviolet. Which wavelength is the smallest? Ultraviolet is smallest. But ultraviolet rays is not going to give you the photoelectric effect. So you need wavelength which is less than the ultraviolet. Infrared is definitely not this. It goes out of the question. This is out of the question. The only question remains are radio waves and X-rays. Now you have to understand which is having more frequency and less wavelength, and the answer is X-rays. Do we understand this?
Yes, sir.
This is how your previous knowledge helps in getting you the correct answer. Do we get this, bacha?
Yes, sir.
Yes, sir. Then, sir. Yes, sir. This is the next question, sir. The work function of metal A, B, and C are falana, falana, falana. According to Einstein's equation, the metal will emit photoelectrons for radiation of wavelength 4100 Armstrong unit. Is are none, A only, A and B only, all the three. Any hope? AIPMT 2005, 2005. Any idea? No idea. Get idea.
We think option D.
Option D, all the three metals. No, my dear friend, you have again lost 5 marks in the IIPMT 2005. Probably you would be of age 4 or 5 years at that time, right? So you are not aspiring to become a doctor, so it doesn't matter.
What is the answer?
What is the answer? The answer is given as C, my dear friends, A and B only. So how do you find out? You have to find out the what? How much energy 4100 Armstrong unit wala wavelength has? How much energy it will have? How much energy this gentleman will have? Which gentleman? This gentleman will have. How much energy this gentleman will have, bacha? 12,400 divided by 4,000. Yes or no?
Yes, sir.
It will come how much? Approximately how much it will come? 3 point something something. Yes or no?
Yes,
3
sir.
point something something, 1, 2, or 4, whatever. This is the energy of the radiation. You can only emit photoelectrons if your energy is more than the work function. Do we know this?
Okay.
Then, sir, what is the answer, sir? The only two radiations which are smaller are 1.92 and 2. Do we understand this?
Yes. Okay, sir.
Okay, sir. Then, sir, let's sir move sir on sir to the next question, sir.
Okay, sir.
Okay, sir. And sir, here, sir, there, sir, we have this question, sir. Oops. This question, sir. A 5-watt source emits monochromatic light of wavelength 5000 Armstrong unit. When placed 0.5 meter away, it liberates photoelectrons from a photosensitive metallic surface. Oops. When the source is moved to a distance of 1 meter, what is the number of photoelectrons liberated? Now again, don't become Gajnis, because you understand, na? You have to remember what we have seen. Yes or no? I told you, a question that will come in the examination hall will be a straightforward one. To remember what we have done. You are there, my dear friends. You are there. Anyone with an answer, sir? I'll give you a minute, sir. Do we have answer here, beta? Shall I do it?
Option A.
Option A. And may I know how do you get this option, beta? Reduce by a factor of half, reduce by a factor of 2, basically. How did you get this answer?
12,400 by 5,000 angstroms
Yes, beta.
by dividing 12,400 by 5,000 angstroms.
12,400 by 5,000. What are you doing, beta? What have you done with the distance? Have you done anything with the distance? Or you are just looking at the distance saying, nah, these are immaterial things and I should not get into all this 0.5 and 0.1. What I have to do with 0.5 meter and 1 meter? Right? Nothing has happened. Is that so? This question has to be solved with 0.5 meter and 1 meter. If you have not used that, well, you have lost 5 marks, my dear friends. And sir, how will I save SOS, save our souls here, sir? I'll again have to take that time machine and go back, and again you have become Gaznis. And it is a very dangerous trend that you have started of becoming Gaznis. I just don't like Gaznis in the class. They are really very, very sick because they can't perform to their potential. I know you guys have a lot of potential, but if you are not performing to that potential, it's a waste. It's the waste of everything that we are doing here. So, well, I can become Doraemon and take you back in time. And when I come back in time, I see this. When I come back in time, I see this. You become Ghazni. 15 minutes before we have discussed this, and you're like, this was useless. Useless, sir. Why, sir? You say anything, sir. It never comes in the exam, sir. Why, sir, I should listen to you, sir? No. Now, sir, can you do it, sir? Or, sir, I need to do it for you, sir. But remember, sir, I will not be there, sir, to solve your paper, sir. Because if I have to be there to solve your paper, sir, I have to split myself all in 6 or 7 or 10 or 15 or 1,000 students who I'm teach, because very difficult for me to split myself. And again, if I do the exam for physics, your biology teacher will have to do exam for biology, so it becomes a tedious task. That cannot happen. Now, sir, can I expect an answer, sir? Now, sir, can I expect an answer, sir? How do we do it now, sir? Intensity, which is the number of photons or the number of photons per second, or the current is inversely proportional to I square, inversely proportional to R square. Do you understand this?
Yes, sir.
Distance, sir, has become twice, sir. Distance has become twice, sir. What will be the number of photons they are reaching, or the electrons which are emitted? Will it increase or will it decrease? You got the answer? You are understanding the logic behind it? Yes or no?
Explain it again.
Explain it again. Okay, so you did not understand it in the first case when we did this. Okay, so the number of photoelectrons which are emitted is inversely proportional to distance. Do we understand this? From the formula that is written there? Yes or no?
Yes, sir.
Yes, sir. So now coming back to the question, what has happened to the distance? Distance has become 2 times. It was 0.5 before. Now it has become 1. It has become twice. Yes or no?
Yes, sir.
Distance has become twice. So intensity, or the number of photons reaching it, or number of electrons emitted, will reduce by a factor of 4. Yes or no?
Yes,
R
sir.
square. Distance ka square. Distance become twice. So it reduced by a factor of 4. Yes or no?
Yes, sir.
If the distance becomes 3 times, it will reduce by a factor of 9. If the distance becomes 4 times, it will reduce by a factor of
16.
If the distance becomes 5 times, it will reduce by a factor of
25.
Do we understand this?
Yes, sir.
Reverse case scenario. If the distance becomes half, it will,
One
if the distance becomes half, then it will,
increases by 1/4.
it will increase by 4, not 1/4, bacha. It will increase by 4. Do we understand this?
Yes, sir.
If the distance becomes 1/3, then what happens? If the distance becomes 1/3, 1/3, then what happens? It will increase by,
Increase by 9.
if the distance becomes 1/4, then what happens?
Increases by 16.
Decreases or increases?
Increases.
Increases. Yes, my dear friends, it increases. Then, if it becomes 1/5, then what happens?
Increases by 25.
Okay, we are coming there. Then, sir, this, sir. Next question, sir. Again, AI PMT 2009. Most of the question can be done orally, sir. Can you get me the answers, bacha, for this one? The number of photoelectrons emitted for a light of frequency F or V, which is higher than the threshold frequency V naught or F naught, is proportional to AIPMT 2009. What is the answer, sir?
Intensity of light.
It depends on what, beta?
Intensity of light.
Intensity of light. Do we understand this?
Yes, sir.
See, sir, we have started to understand things, and as you can see, questions are pretty damn simple and pretty straightforward, and you will be surprised to see some of these questions still coming back to haunt you. AIMS 2004, AIMS ka exam, there was a point in time where AIMS had a different exam. AIMS 2004, that is the question. A photon of energy 4 electron volts is incident on a metal surface with work energy 2 electron volts. The minimum reverse potential to be applied for stopping the emission of electrons. How much reverse potential? Now, what do you mean by reverse potential here? Can anyone tell me? They are talking about which potential, bacha? You say, sir, I have never heard the term reverse potential, sir. What is that, sir? So, what is that answer, sir? What do you mean by reverse potential? I have to stop the emission of electrons. So, what do you mean by reverse potential? The answer is given in the question itself. What do you mean by the reverse potential? Reverse potential stands for?
Reversing of cathode and anode.
So, basically, we are talking about which term? Stopping potential, yes or no?
Sir.
So we have to tell me, you have to tell me the value of stopping potential. Work function is given to you. Energy of the photon is given to you. Energy of the photon is 4 electron volt. Work function is 2 electron volt. What will be the maximum kinetic energy? Maximum kinetic energy will be 2 electron volts. Yes or no?
Yes, sir.
From this maximum kinetic energy, this should be equal to E into V naught, where E is the charge of electron and V naught is the stopping potential. Yes or no?
Yes, sir.
2 EV, E say E gets cancelled, and the stopping potential is 2 volt. Do we understand this, bacha?
Sir.
Yes or no?
Sir.
As I say, sir, most of the questions that you see, sir, are straightforward questions, sir. And I don't need any proof. The question is right there in front of you. Give me the answer to this one. In photoelectric effect, the electrons are ejected from metals if the incident light has a certain minimum. What? AB? CD?
Minimum frequency.
That frequency is known as what, bacha?
Threshold frequency.
That frequency is definitely known as your threshold frequency. That is correct. Looking for more questions. And again, here is this one. And what I'll do is I hope that you will get the sheet by today and you can solve the rest of the question. The graph wala part is remaining, so we will discuss the graph wala part. And we'll not be doing question on graph wala part because graph wala part is question in itself. Which of the following statement about the photon is incorrect? Read the language carefully. Incorrect. Incorrect. Incorrect.
Photon exist pressure.
I think we have done this question. It's got repeated. Sorry.
We done this question.
Sorry. Yes. Now I remember.
D answer.
No, sir. I remember, sir. I understand my fault, sir. Don't worry, sir. I will rectify my fault, sir. And sir, what, sir? This, sir. That, sir. Again, this is a question taken from engineering. BHU, Banaras Hindu University. There was a point in time when I was of your age. We had a separate exam for BHU. It was known as IIT-BHU, Institute of Technology, Banaras Hindu University. Now it is known as IIT-BHU. Anyways, doesn't change anything. Question can get repeated. Photons are emitted by metal surface only when what? Which option is correct?
B and C are not correct.
Only one option is correct. B and C are not correct. Na. You have not read the question correctly, beta. Na.
D answer.
Answer is?
D.
Answer is D. Wow.
There is no charge, no photoelectrons are.
The answer is C, my dear friends. It has to be more than threshold frequency. Is it difficult to understand, bacha? Straightforward question with a straightforward answer. It has to be more than threshold frequency. Do we understand this? Yes, sir. No, sir.
Okay, sir.
Better I go, sir, because the time is over, sir.
Okay, sir.
So I will end this class here at this point in time. I think we have done enough questions. The rest of the questions are just repetitions of what we are doing. So I'll hope that you will get the sheet and you should be able to do it by tomorrow. Tomorrow we will finish the last part of this chapter and move on to the next topic. I've already discussed graph, but I still discuss them again once more in great detail, because I know the only question that are going to come are either of this type or from graph, and one question should come from this topic. And I don't want you to lose 5 marks. Okay, so I'll continue with this topic in the next class. I hope you found the class entertaining, not entertaining. You found the class rich and you have gained something from this. With these three classes, you should be able to solve all the questions that can ever come. So I'll wind it off here.
Okay, sir.
Take care. Have a nice day.